Good morning, everybody, and welcome back to Next Door NetAdmin. I thought I'd take a short break from my Active Directory series that's still ongoing because there's a lot to cover. But today I thought I'd take a break from that and talk a little bit about the Windows Registry. This is a question that was submitted by the Guy, and it's a little bit about what exactly is the Windows Registry. Everybody knows that it exists. Some admins, probably most admins really, have had a little bit of a poke around inside of it. But what is it really, and how does it function? At its core, the Windows Registry is a database of name value pairs, and that's pretty much it. It is organized hierarchically, and we'll take a look and see a little bit of what that looks like. If you start by just opening up your registry editor, you'll see that we've got 5 main folders at the top: HKey classes root, HKey current user, HKey local machine, HKey users, and HKey current config. What exactly are these? What do they do? Well, if we take a look at some of the Windows documentation for it, and yes, this is registry information for advanced users, you'll notice there's a lot of legacy information in here, but let's go through it a little bit. It was used in 98, Windows CE. Who even knows about Windows CE these days? NT 2000, etc. But okay, we've got registry hives here. What's a hive? Stick a pin in that. We'll come back to it later. But we've got SAM, that's the security account manager, I believe. Security for other security related things, software, system. All of these apparently are under HKey local machine. Then we have HKey current config, has a whole pile of supporting files, and HKey users default. And then it goes a little bit into what these particular folders are. Okay, well, what exactly is a hive? You can think of a hive as a database file. This is hierarchical, so you can load different hives into the registry and essentially connect them to make their values available. And in fact, Windows does this on a regular basis because every user has their own registry hive. Okay, how do we know this? Well, when we look at all of these supporting files, okay, where precisely are these? Where can we go look at them? Well, most of them are in the system root system32 config folder. This says all the way up to Vista. I'll give you a hint, it's still there now. And the supporting files for HKey current user are in system root profiles username. It's not under profiles anymore. It's under system root users username. So where exactly are these files? What do they look like? Well, see Windows System 32 config. I had to add myself permission to view this folder, so you may not have permission to go see it yourself. But in this folder, we've got a lot of these files: SAM, security, software, system. There's even one for default. There's a BCD template, that's for your boot configuration data store. Fun fact, the boot configuration data store is actually a type of registry file. It's not exactly the same, but it uses some of the same formatting. These are binary formats. There is no specific file type. And if you opened it in Notepad, you'd probably get a whole bunch of gibberish. I'm not opening it in Notepad because the registry is really one part of Windows that you don't want to have to futz around with more than necessary, because Windows depends on it for pretty much everything, and we'll see that as we continue through the documentation. But okay, this thing also said that for default log, default.save. Okay, interesting. But we also saw that HKeyCurrentConfig has NTUSER.DAT, and this would be under profiles username. It turns out if we go and look at the default user, C users default, we can see that there's a default NTUSER.DAT. NTUSER.DAT in the profile folder is the user's registry hive, the one that is specific to the user. If we go into the registry editor, you can see that HKeyCurrentUser is also there with HKeyUsers. HKeyCurrentUser is the section that pertains to the currently logged on interactive user from the perspective of their own session. And when you go to HKeyUsers, you've got default, you've got a few system-specific ones that are just default SIDs, but then you have a user SID. And yes, this is the same as the object SID if you were looking at it in Active Directory. And then you have the same value, but underscore classes. Okay. Turns out if you expand this one user that's currently logged in, hint, it's me, you see exactly the same list of values as you see under HKeyCurrentUser. Cool. I am the person who's logged in. You can access that through HKeyCurrentUser. But how does this change if you've got multiple users logged in at the same time? Well, HKeyCurrentUser will still be the current session that is actually running Registry Editor. But it turns out you can actually interact with other registry hives if you have the right permissions to do so. And you can even load those hives if you have A, the permission to do so, and B, access to the registry hive file. Here's an example. If I had computer highlighted, load hive doesn't exist. Or excuse me, it's grayed out because you don't really have the capability to add something at this level. But if you go to HKeyUsers and highlight that, you can go to File and load a hive. And when you do, you can go to C users, go to the administrator. This is the machine administrator. And you can see there's an NTUSER.DAT. If I select that and load it, I have to choose a key name. Normally, this would be the account SID. I don't happen to know what the SID is, so I'm just going to call this Z administrator. Prepending it with a Z just means that you're going to know it's at the bottom of the list, and it makes it pretty clear that it's not a value that Windows mounted on its own. And there it is. So now this section is actually being referenced through the NTUSER.DAT file under C users administrator. It's a completely different user hive. I still have my own hive loaded because I'm logged on to the system right now, and HKeyCurrentUser still references me because this is my session that registry editor is running in. And you can see because there's a volatile environment key here, which matches the volatile environment key there, but there is no volatile environment under administrator because A, it's not logged on, and B, it's not the one in this session. So you can actually load and modify parameters in somebody else's user hive, and then when they log on, what you put in their hive will become whatever is in HKeyCurrentUser, because then they will be the current user. So just a little trick for being able to modify parameters for a user even if they're not logged in. You can still load their hive and put registry settings in there for them. HKeyLocalMachine had a bunch of things underneath it, software, system, etc. Some of this is reflected in HKeyCurrentConfig, but most of the time I will be working through HKey local machine, and probably most of the time you will too. Of note, under software, along with a bunch of other software that's available, there's this interesting one called WOW6432 Node. That's a little bit of a special one. On a 64-bit version of Windows, most of these keys are for the 64-bit version specifically. Same as System32 has your 64-bit files. But if you need to adjust registry keys for something that is 32-bit specific, you'll find that under WOW, which is Windows on Windows, 6432 node, and there's a few things here which are specifically 32-bit. And that kind of corresponds to, instead of, not that one, if instead of System32, you went into syswow 64, Windows on Windows 64, then these are the files that you have specifically for 32-bit applications for compatibility, essentially. So it's the same way that you have these files, you also have a section of the registry to handle the registry parameters for those files. All right, let's get back to the documentation here for just a second, because sure, there's a lot of these files. They're important to know what they are, more specifically so that you don't futz with them unnecessarily or know what you need to back up. It's not so much for directly accessing them. A lot of this goes into much the same as I already discussed. HKey users, all the actively loaded user profiles on the computer. Cool. HKey current user, the user who's currently logged on. All right. HKey class's root is the information that makes sure that the correct program opens when you open a file in Windows Explorer. It's your application associations, essentially. But not just that, HKey class's root also contains the information that says, hey, if I right-click on a .txt file, what are the other options that show up? If I right-click on a .cmd or a .bat, there's an edit option. How does it know what program to open when I click edit? Because if I double-click it to open it, it'll load in command prompt and it'll execute the file. But if I do edit, it opens in Notepad for editing. So HKey class's root is not just your application associations for what you double-click, but it also contains the definition for all of the other items that can show up in your right-click context menu. To me, that also makes this a little more difficult to interpret. A little bit. So it's one that I don't do a lot of work in, and I try to use menus and other application-specific methods to manage the default associations and the default actions. This is more about the WOW6432 node. All right. And then, we've got some registry data types. One of the most common that you'll see is regd word. That's a double word. A word is 2 bytes, so a double word is 4 bytes long. There's also a Q word for quad word, and that is going to be 8 bytes. Since each byte is 8 bits, it's a 64-bit integer, a 64-bit value, a quad word. Reg string is definitely a string value. Reg multi-string, okay. A variable length string, all right. Do you know why these all end with a Z? Is that just a way of saying strings? I mean, good guess, but no. Because, for example, one string value is just reg SZ, or Z if you're American. So what is this? Do we know why it ends in a Z? I don't know for sure, but I have a pretty good hunch. It turns out text strings are terminated with a null value, which is literally 0, hexadecimal 0. That's how it knows that it has actually ended the string, and whatever follows is the next name value pair. Interesting. Well, okay, so that's interesting. It's a null value. Is this useful to us at all? Only if you're going to go digging a lot further into the registry. In fact, as you can see here, you don't necessarily have every string in the registry terminating with a null character. It's supposed to, but it doesn't actually. As Raymond mentioned, this is all the way back in 2004. Imagine that. You can lie and get away with it. He demonstrates it in this program that he wrote to show this behavior, but essentially, you can tell the registry, hey, this value is 2 bytes long, when actually it's 6. The registry records the reported value of 2 bytes and reports that back, but it's not actually. This has been a source of some interesting security facts, where something like the registry editor may actually only display the length that the string claims. If the registry editor looks up the value and it says, oh, this value is 2 bytes long, so I'm going to display 2 bytes of data in the GUI. Okay, but what if there's actually more data in there? As it turns out, some tools, such as Registry Editor, I don't know if this is still the case in the current day and age, but it certainly used to be the case. Registry Editor will display only as much data as is reported. But when Windows actually interprets the value in the registry, it'll keep reading the whole thing until it reaches the null terminator. Which means that your tool might show you 2 bytes, but you can pull actually 6, and Windows will interpret all 6 bytes. So it was a great way to stash data in hidden locations in the registry that you just couldn't view. If your tool just relies on everything being exactly what it says, then it might show you something that is completely different from what's actually stored in the registry. So the registry can be a wild place to be. This has security implications. Yes. Here's another one that he calls out. If your program assumes that all the strings in the registry are always null terminated, you can be tricked into a buffer overflow, if you find a string value which is not null terminated. And yeah, he notes it really shouldn't have been possible to get into this state in the first place. This is a registry design that dates all the way back to Windows 98. It is well on its way to being almost 30 years old at this point, if not already. So the registry is very much a legacy design, and this is also why it's not a great idea to go meddling around in it, because you might think it's supposed to work a certain way, and it might not work that way. There might be undocumented behavior, there might be code that is in there specifically to handle bugs that doesn't react well to whatever it is you're doing. It's entirely possible to just break Windows entirely because so much depends on it. What kinds of things depend on the registry? Well, group policy. All that group policy is, and we'll cover group policy more when we go back to looking at Active Directory, is setting registry values to control behavior. And typically there's an actual policies key in the registry where all of these policies, or most of them, are saved under. You can use a .reg file to merge changes into the registry. Many people have seen this. WMI, Windows Management Instrumentation, can change the registry, and it can also pull values from the registry. So there are a lot of things that can be used to fiddle with the registry. And these were things to fiddle with the registry, and I said they were things that depend on the registry. But yeah, I said that wrong. But things that depend on the registry are basically most programs. Most programs that have preferences or programs that check for policies to be set will be looking at the registry. And a lot of this is because this was what Microsoft came up with to get rid of the .ini files. It replaces most of the text-based ini files that were used in Windows 3 to point whatever and MS-DOS. So where you used to have a bunch of initialization files to control the parameters of the program, and they could just make those changes in that file. Now there's just a centralized database where programs can say, I'm Windows Explorer, I'm going to store a preference there. Window size, window position. I'm going to store the preference that this user wants to see hidden files but doesn't want to see file extensions. I'm going to store a policy from the administrator in group policy that says the C drive is forbidden from being displayed. Okay, then it won't display the C drive. I have a policy that says no local drives whatsoever. Okay, so C, D, and E all happen to be blocked, but X, Y, and Z as network drives are displayed. You can set that up. There are other policies, and other programs can look at policies. Firefox has policies that you can set with group policy, and it will go look for those policies in the registry, and it will obey them. You can set policies for many programs, or preferences, or just configuration instructions. You can do all of this in the registry, which makes understanding the registry and understanding how dangerous it can be is a very important thing for an admin, particularly the danger. Standard, caveats apply. Everybody always says, make sure you back up the registry before you do anything. And that's not bad advice. I don't necessarily do that. A, because the registry is usually part of a system level backup that I'm doing anyway. And B, I also know that I'm not going in there to just meddle and tinker with things. I'm usually following a set of instructions. And I'm really confident in my ability to actually execute those instructions correctly. But if you don't know what you're doing, or if there's any doubt in your mind, definitely take a backup of the registry before you actually start meddling. And then maybe you can actually restore it to how it was if everything should go crazy. So there's your standard caveat. That should be a really quick, really brief look at the registry and a little bit of a discussion on what it does and what your dangers are when you're working with it. Hopefully that was interesting or enlightening to you. If you have other thoughts on things that you'd like me to talk about or things that you'd like to see me demonstrate, feel free to let me know right down there in the comments section. Otherwise, thank you very much for watching. I am your next door NetAdmin, and we will see you next time.